Before we move on to systems of equations, solving systems, the chalk disappeared. Before moving on to solving systems of equations and explaining to you what that is, I want to go over two of the problems that were on the worksheet from yesterday. They're word problems, of course. And number 2 was a little confusing, and also number 5. And so we're going to write these equations of lines and show the class how to work those. The wording is different. You still use the same equations. So I'm not going to write the entire problem up there. I'm putting it here so you guys can write it down. Writing the equation of a line, we know that we're going to use this formula. Because it says to write the equation of a line. Now let's look at all of the information that we have. They give us the point that it passes through, and we're familiar with that. They said, write the equation of a line that passes through this point right here. So this is our x1 and our y1. Now the other part is what's confusing. And it says, I want this line to be perpendicular to another line that goes through these points. Okay, so I'm going to write the equation of a line that goes through this, and the information that I'm missing is the slope. If you've been doing the other problems, you'll find out that all we need is a point and a slope to get the equation of a line. Well, here's the other clue they give us right here. They said, I want it to be perpendicular to this line.
Is it because it's different?
Yes, this is a different line. We're not going to write the equation of this line. The only thing we want out of the perpendicular or the parallel is the slope, right? That's all we want. So you know a slope formula.
I know how to do it.
Yes.
And you got to do all over again the y minus y1 and the x minus x1.
Yes, you could, but there's a shorter way.
Okay.
All I need is the slope. Now, if you forgot, then do it your way. But don't we have a slope formula?
Yes.
Remember just how to find the slope. It's this one. y2 minus y1 over x2 minus x1. Because all we need out of this perpendicular line is the slope, right?
Yes.
So this is our x and our y. X and y, these are the ones, these are the twos. And so y2, 6 minus y1 over x2 minus x1 equals 2 over 2. So the slope of this line is 1. Okay, and slope is usually here, right?
Mm-hmm.
Okay, so a perpendicular slope, perpendicular to this, means that we have to flip the slope and change the sign. So flipping it looks about the same. So a perpendicular slope, we're going to flip this. So it's still going to be 1 over 1, but then change the sign. This means perpendicular. The perpendicular slope to this, you flip the fraction and change the sign. So now over here, we have everything we need. We have the perpendicular slope. That's all we needed out of that whole mess is the slope. And now we're back to our original. We want to write the equation of a line that goes through this point on the graph and has this slope. Okay? And I think I'll show you something on the graph that might be kind of cool. Okay, that's why let's see. Have you got all of this information?
That's fine, go ahead.
You do?
Mhm.
Okay. I'm going to leave this because we're going to show you what this actually means on the graph. But right now, let's get the equation of this line. Okay, this is for later. Okay. So now we're writing this equation. So y minus y1 is -3 equals, our slope is -1, is x minus x1, 7. We know this is a plus, 2 negatives make a plus. We have to do, use the distributive property to expand this out. So now I have y plus 3 equals -1x plus negative times a negative is 7. And I want the y by itself, so I'm going to subtract 3. And so the equation of this line is y equals -x. They probably won't put the 1 in the answer sheet. Plus 4. You want to check that on the answers and make sure? I guess I've got the answers right here.
Yep.
Okay. Oh, it's in a different. Yeah, don't worry about that. It's correct. Okay. All right. Now, what I'm going to show you is, let's graph these two lines. Here's the one that we wanted the equation of. So we're going to call that L1. And here's the one that we wanted it perpendicular to. We're going to call this one L2. I'll move the screen here and we'll go to we'll go to our graph here as much as you can see. All right. So our original, the one that let's do L1 and L2. Okay. So if I'm going to graph L1, I need to find this point. Are y'all okay with that? Okay. So I'm going to find that point. It's 7, -3. So here's 7, 1, 2. Here's that point. And then the slope says rise over run is over. So I'm going to go down 1 and over 1. Down 1, over 1, down 1, over 1. Here's my line. Forgive me while I go get a yardstick. And we will draw this line. I'm just gonna. Okay. Okay, this is line 1. This is the one they wanted the equation of because it goes through this point and has the slope of -1 over 1. Now let's look at the perpendicular line and see if we did it correctly, because if we graph the perpendicular line, it should make a 90-degree angle with this line somewhere. Okay, so they gave us 2 points. They gave us 1, 4. See the perpendicular line over there? And they said the point is 1, 4. I'm right here.
Yeah.
Okay, so I'm going to 1 and 4. 4 is right here. And then I'm going to go to 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. And I will draw that line. And you can see what they were telling you over there is they want you to write the equation of this line that is perpendicular to this line. Notice how they cross right here at 90 degrees. Okay? Where they're crossing right at 90 degrees. The two lines are perpendicular. If that helps any. 9, 2. I see your face. All I'm doing here, you don't have to do this. All I'm doing is trying to show you that sure enough, we did come up with the line that was perpendicular.
It's graphing the slope same.
That's all I'm doing there. Okay, or here. That's all I'm doing right here. You don't have to do this. Sometimes it's nice to see the visual. Okay.
I will eventually though, right?
Yes, you will eventually. Yes. All right. And then number 5. And again, these are word problems. And if you're not used to doing word problems, they're going to be difficult until people help you through a few of them. And you'll start to see how familiar they are. You just have to continue to work at it. Okay, let's look at number 5. Here's number 5 again. You want to write the equation of a line, and they're going to call it line U, that passes through this point and is parallel to this line. And that's the confusing part after that, right? After the parallel, kind of confusing. All right. So, of course, it says write the equation of a line. So I have y minus y1. Same familiar formula if we write the equation of a line. Now let's see what information we have. We want to write the equation of a line U, they just call it U, passing through this point. So this is familiar to us. X, Y, there is our point, our X and our Y. And parallel. This should go ahead and say something to you already. The line V, parallel to line V, that cuts the X and Y axis at X equals -3 and Y equals 6. So this line, I just want the slope out of this stuff right here. I just want the slope, but it's worded differently. So you need to think about this. It says parallel to the line V that goes through here and here. Well, think about this, okay? Here's the X-axis, here's the Y-axis. So they said this line right here goes through X equals -3. So here's X, 1, 2, 3. Here's that point. And then Y equals 6. 1, 2, 3, 4, 5, 6. Here, this is 6, and this is -3. What you need to do, you need to know what the coordinates are of this point. Of course, it's 6, but how do we write its address? If I'm going to write the address for this point, I'm going to say -3, 0. Do you see? Okay, and then if I'm going to write the address for this point right here, it's going to be 0, 6, right? So if I have 2 points on a line, I wonder how I could find the slope, because all I need out of here is the slope, right? How am I going to find the slope?
By using the y2, y1,
The slope formula.
x1,
Yes,
x2, y2.
you are absolutely correct. So now that I have 2 points right here, and all I need out of this bunch of the word problem, I just need the slope. So I'm going to do not y. I'm going to do m, slope equals y2 minus y1 over x2 minus x1. So the slope for this line is, here's our, let's do this, x and y. Let's make those the 1s. X, y, we'll make those the 2s. So I have 6 minus 0 over 0 minus a negative 3. So the slope of this line, not the one I'm writing the equation for, but this line, is 6 over 3. So the slope of this line is 2 over 1. We had to do that work because we needed the slope. We needed to know what slope we're going to use in our problem. Okay, now it says parallel to this slope. What do we know about parallel slopes?
They're beside each other, they're the same.
They're the same. They're exactly the same. So if I want this line to be parallel to this line, I have to use the same slope. So I'm going to use the slope equals 2. I'm going to use the same slope as this line. Now I don't need any of this anymore. I just need this to find the equation of a line like we've been doing all along. Little bit, tiny bit. So we have y minus 9. I'm going here. I'm writing the equation of this line now. Y minus 9 equals the slope times x minus 8. I'm multiplying. So I have 2x minus 16 so now I have y equals 2x minus 7. This line will definitely be parallel to this line because they both have the same slope. Okay. Okay, let's move on to systems of equations. This you will be able to do. You will be graphing on graph paper. So we're going to review how to graph an equation from the equation. Now, when you do systems, it's going to be very important to have a straight edge and graph paper instead of just making just a little draft on your notebook paper. You'll need actual graph paper, a sharp pencil, and a straight edge for systems. But as an intro to systems, we're going to remember how to graph an equation. So let's say we have y equals 1/2 x minus 4. Okay? So what we need, remember that this is, here is the pattern for this. So the m, or the number in front of the x, is the slope. And this will always be the y-intercept. It will be a point on the y. So when you look at the equation that we're working with right now, you need to be able to pick out two things. You need to be able to tell me what the slope is and tell me what the y-intercept is. If you know these two things, you can graph a line. You don't have to use a t-chart, anything. So this is the problem that we're working. So what's the slope out of this problem? It's solved for y. So the slope is
1/2.
1/2. And our y-intercept is
4.
-4. Be sure and use the sign. All you have to do when you know these two things to graph this line is to graph the y-intercept first. Remember, if it says y-intercept, then this is on the y-axis. Here's the y-axis. I'm going to find -4. Right here. And what I like to say is, this is my home. I live on Y. This is always my home. This is where I be. One of my students told me. They said, this is where I be on the y-axis, okay? That's how she remembered. Now I use after I've graphed that, I use my slope as a GPS that will get me to my friend's house. The top is how far I rise. The bottom is how far I run. Okay? So from my front door, I'm going to rise 1 block and I'm going to run 2 blocks. So right here is my friend's house. And now all I need in order to have a line, to create a line, is 2 points. That's all I need. So here we go. Now this is when you have to be very accurate on your graph paper when we do systems, and you'll see why in just a minute. So here's the line. So that's a review on how we graph a line from the equation. All you need to know is the slope and the y-intercept. Now, remember, you cannot pick these out until the equation is solved for y. Y has to be by itself before you can do that. Okay? So now let's move on to systems. It sounds like a really big deal. Systems simply mean that there are 2 equations, and we will graph both of those on the same graph. Okay? Systems. Systems mean a group of 2 or more graphs that are graphed on the same coordinate graph, okay? Lines. I'll show you. Now, sometimes we could have 3 equations, we could have 4 equations, but you will only deal with 2 equations, and we will be able to solve those by graphing. So we're going to look at the very first number 1 on the packet that you received in your email. It says graph each system of equations and find the solution. And find the solution. So I'll show you where the solution is. Now notice that both of these equations are already solved for y, so that's a good thing. So we're going to graph both of those. Now my coordinate graph is kind of far from the remote people, so I'm just going to do it here for the first couple of times. So it says graph this system. So here's the first equation, equals 6 minus 2x. Here's the other equation. Y equals negative 4x plus 16. Now what we're supposed to do is graph both of these lines on the same coordinate graph. And your worksheet has actual graphs for you. Okay, for this equation, you need to tell me the M and the B. We're going to graph this. So looking at this equation, we have to first decide if it's solved for Y, and yes, it is. So you can look in this equation, find the slope for me.
2x. Negative 2x.
Negative 2,
Oh,
no x.
okay, negative.
Okay, so it's negative 2 because it's the number in front of the x. So it's negative 2, and because we need a rise and a run, we're going to put this over 1. Now, what is B?
6.
6, a positive 6, right?
Yeah.
And all we need to graph this equation is right here. So let's do that first. This is where I be on the y-axis. 1, 2, 3, 4, 5, 6. Okay. And then from my front door, I'm going to rise a negative 2 and run 1. 1, 2, and here. So be sure and use y'all's straight edge. Okay, that's this one. We're going to graph the other one on the same graph. So now we're going to look at this line and we're going to say, is it solved for Y? Yes, it is. Y is by itself. So tell me what the M is, the slope, and tell me what the B is. The slope is?
Negative 4.
Negative 4, and since we need a rise over a run, we'll put it over 1. And B is?
16.
16. Didn't make my graph large enough. Okay, so I graph where I be on the y-axis first on 16. So we're going to kind of go up here. Okay, this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I just needed extra room. And then from there, I'm going to rise a negative 4, 1, 2, 3, 4, and run 1. And again, I'm going to freehand. Okay, now you have both of the lines graphed on the same graph. The solution is where they cross. This point right here. Now, since I didn't use a straight edge, and this isn't accurate graph paper, I'm going to just guess, and then I'm going to look at the answer. Okay, so it's about 1, 2, 3, 4, 5, 6, maybe 7. 1, 2, 3, maybe 7, negative 3. What you do is find out what the address of this point is where it crosses. That is the solution. The solution is where these cross, where the two lines cross. Okay, that's why you have to be very accurate when you graph these with your straight edge and your sharp pencil. Oh, I wasn't too far off. It's really 5, 4, but that's because I wasn't accurate. But when you use your graph paper, you will know exactly what this point is. Any questions on that? Not for right now. The only difference on this page and the next 2 pages, you are solving these systems by graphing. The only thing different on these problems on the first 3 pages are that some of the equations they give you will not be solved for Y, And you'll have to get the y by itself before you get your slope and your y-intercept. That's the only difference. So you're going to practice, 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 practice. If it's solved for y, you can pick out your slope, your y-intercept. If the equation is not solved for y, you're going to have to stop and solve for y first. And then pick out the slope and the y-intercept and graph both of them on one graph. Where they cross is the solution. So are you okay to start trying? Yes, we are. We're so excited about graphing systems. I will see you all Monday. We're going to solve systems by substitution on Monday.